Bismillahirrahmanirrahim. Assalamu alaikum. This is Javeera Ahmed, roll number 2022 CE10, Computer Engineering Department, UET Lahore. So today I will discuss the lecture 16, Program Design. This is an overview of lecture 16. Program design is the backbone of software development in guiding how systems are structured and built. The approaches that we will discuss include heavyweight and lightweight design, tools like UML diagrams, and iterative processes to refine ideas. Key aspects include identifying application and solution classes, understanding static and dynamic modeling, which we will see in more detail, and managing relationships between components. Reusable design patterns such as the observer pattern uh, provide efficient solutions to common problems, ensuring systems are consistent and maintainable. With modern tools and techniques, program design balances flexibility with the need of clear documentation and robust structure. So this was an overview about my presentation. Okay, now I will start with the details of this lecture. In start, we have program design models. Some people like to keep program design and coding separate. This is the main thing in this lecture. Program designs use models like UML diagram and specifications and then use modern tools to integrate them. Mostly this is used in agile approach. Take software and then represent it in a way that it can be implemented. Program design specifies the programs, components, packages, classes, interfaces, protocols, etc. It must be done properly as all important design decisions are made before implementation. Implementation should focus on coding. Then we have heavyweight design and lightweight design. In heavyweight, the goal is entire specification must be completed before starting code. But in lightweight, we start with outline of requirements, but we complete them as part of coding process using language-based tools like IDEs, etc. Nowadays, we don't mainly use heavyweight methodology only. UML model choices. We have diagrams that are used to represent requirements like use case, where we have use cases, actors, and relationships. For architecture, we look to component diagram, which shows organization of dependencies among component, and deployment, which shows the configuration of processing nodes and the components that execute on them. We have two models that are mainly used for program design. First one is structural, static, or class model, and then we have the object or sequence diagram. Structural modeling focuses on the static aspects of a system, meaning the parts that don't change during execution. A class diagram is common example. A class diagram has four portions. First, uh, includes the name of class that starts with the capital letter. Then it has the name of attributes that are related to that class, like shown here. Then then the third portion includes methods, and fourth portion shows optional references. It shows the classes in a program, their attributes, and their methods. For instance, in a Hello World program, we might have a class called Hello World with a method called paint that displays text on the screen. This kind of diagram helps developers understand the structure of program at a glance. Then we have relationships in program design. Relationships between classes are key part of design. They show how different parts of the program interact. For example, associations represent links between classes, like the relationship between a library and its books. These are represented by solid line with multiplicity at each end, like this one shows association. Then we have dependencies, which shows that a change in one class might affect another, represented by dashed arrow with stick head. Then we have generalization that represents inheritance, where a child class shares properties with its parent class, represented by solid arrow with an enclosed head pointing from child to parent. Aggregation and composition show how classes are made up of other classes. These relationships help create a clear and logical structure. Then we have, okay, so you can see this diagram as well. It is an example of what I have discussed earlier. Tools for UML based design. There are many tools available for creating UML diagrams. Tools like rational draws make it easier to draw and manage these diagrams. Some modern tools even allow developers to generate diagrams from source code or create specifications directly from comments. These features save time and reduce the need for manual updates, ensuring that the design stays consistent with the code. For lightweight design, sometimes a simple whiteboard sketch is enough to brainstorm ideas. Then we have class design. Designing classes is an important part of program design. It begins with identifying the main elements of the system. For instance, in a library system, key classes might include key, books, members, and staff. Each class should have clear responsibilities. Attributes and methods should align with the class that needs with what the class needs to do. Once the classes are identified, they are refined to make the design clear. This might involve merging similar classes or splitting up complex ones to ensure that each class is focused and easy to manage. Then this is an example you can see in the notes as well. This basically identifies uh, the noun from the specifications. Like here we have library, books, and journals, and much more. This shows whether they can be candidate classes or not. Like if you Google it, so you can see that if we have a main class as animal, then the candidate classes are uh, then like we can include duck, etc. So these are the candidate classes, but main class is the animal. So here main class is library and book, journal, copy, etc. These are the candidate classes. So you can learn from this example. You can see this example in your notes as well. Then this shows the relationship between them. Now moving towards the final design. As the design progresses, it's important to refine and improve it. Reusing existing components or libraries can save time and effort, but they might need to be adapted to fit the system. Restructuring the design to improve clarity and maintainability is another important step. Performance requirements might lead to optimizing algorithms or reorganizing the parts of the design. This process is iterative, meaning it involves constant review and adjustment. Each iteration brings the design closer to its final form. Class design advice. The classes should be intuitive and easy to use. They should be also be hard to misuse, meaning the design should guide developers toward correct usage. Reducing dependencies between classes is another key principle. When classes are too tightly linked, it can make the system harder to maintain. Avoiding cyclic dependencies where classes rely on each other in a loop is especially important for portability and flexibility. Then we have dynamic modeling. Dynamic modeling focuses on how the system behaves during execution. Interaction diagrams, such as sequence diagrams, are used to show how objects interact over time. For example, a sequence diagram of a student management system might show uh, the flow of messages when a student's program is changed. This helps developers understand the timing and sequence of operations, making it easier to spot potential issues. Here, object notation, I will explain in some detail. Okay, so basically, this an object colon any class means that an object of a class. Then uh, colon any class means an object, and so does this. The names of the objects are underlined. Then we have message notation. These are basically the lines that we will use in uh, basically it is a notation that we will use in our sequence diagram. So class notation and message notation. In UML, classes are represented using simple notations that include their name, attributes, and methods as I discussed earlier. Messages between objects are shown as arrows in sequence diagrams, which labels indicating the operation being performed. These notations provide a visual way to understand the system's behavior and structure, simplifying complex relationships. Then we have, okay, this was a mainly example of changing student program. So, firstly, we will take the name. Then, this one was the line used for return status. Okay, so it returns the name, and then this is used to return copy. Okay, this used to call a function. We called it PhD student. We created a PhD student with giving the attribute name, and then this line was used to destroy. So we destroyed the data in this program, and then we created a student or like changed the student program from M engineering student to PhD student. Then we have design patterns. Design patterns are reusable solutions to common problems in software design. They save time, ensure consistency, and provide proven ways to handle recurring challenges. For example, the pattern is used when multiple components needs to respond to changes in one object. Observers automatically update whenever the subject changes, which is in common graphical applications where actions trigger updates across different elements, like we see in our daily lives. Each design pattern has a meaningful name and a clear problem it solves. It includes a template for the solution, which can be adapted to various situations. Patterns also highlight their consequences, helping developers weigh trade-offs. For instance, while the observer pattern reduces coupling between components, it can make control flow harder to trace. Then we have implementation patterns. Patterns often use inheritance and interfaces. Abstract classes define common structures, while concrete classes handle specific implementations. This makes them flexible and adaptable to different systems. Then we have observer pattern. The observer pattern is especially useful when changes in one object need to affect across many others. In a graphical interface, for example, a button click might update multiple elements. This pattern keeps the subject and observers loosely connected, making the system easier to maintain and expand. Thank you so much for listening.